determine if the series converges or diverges. If it converges, determine its sum. So we got 1 over n minus 1 over n plus 1, and n runs from 1 through infinity. If we write down the terms, so we are essentially finding the sum, take n equals 1. So 1 over 1 minus 1 over 2, so that's the first term when n equals 1, plus, that sigma means plus, take n equals 2. So 1/2 minus 1/3 plus n equals 3. 1/3 minus 1/4, 1/4 minus 1/5, and forever. So we want to find its sum. If the sum is a finite number, then we say the series converges, otherwise it diverges. But if you look at this closely, this 1/2 cancel. So 1/3, 1/3 cancel. Negative 1/4, positive 1/4 cancel. Okay. If we had written another term, that would be n equals 5 1/5 minus 1/6. Then that would cancel. That means only very first term survive, and I don't know which one. So for this type of series, when there is a lot of collapsing, like Pirates telescope, this is called telescoping series. To find the sum, or to check if it converges or diverges, we need to find some nth partial sum. I mean, this one is like sum of first term, just first term, and this if we write down these two, that would be sum of first two terms that we denote by s2. If we take first three, etc., and we want to find the sum of the first nth terms. N could be like 10 or 20. Okay, we find this one, and then using calculus 1, we let this n go infinity. That means we are capturing all infinitely many terms, and whatever it comes out, that will be the sum. If it is a finite number, then the series converges and we have the sum. But if it comes out to be like infinity, then the series diverges. So we need to determine nth partial sum. That means sum of first n terms, where n is any number. It's a generic number, n, maybe 10 or 20 or 1 million, we don't know. From here, we just saw that. I mean, this is just the scratch work now. We don't need this anymore. That's just the. So S1 means sum of the very first term. I mean, that's the first term. So 1 over 1 minus 1 over 2. S2, sum of the first two terms. That means these two. 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3. Okay, then S3. In this way, we will write Sn. Okay, I'm just trying to find a format. 1 over 1 minus 1 over 2, 1 over 2 minus 1 over 3, plus 1 over 3 minus 1 over 4. I mean, sum of the first three terms. S4 would be then 1 over 1 minus 1 over 2, plus 1 over 4 minus 1 over 5. We don't really need to write down all of them. Okay, I'm just trying to find a pattern. Starting sum of first two terms, we can see 1 over 1 minus 1 over 3. That's the only thing left. Here, cancel. So just 1 over 1 minus 1 over 4. Here, 1/2 cancel. 1/3 cancel. 1/4 cancel. Very first and very last. Okay, that means in this way, if we keep writing in this way, we'll see only the first term and the last term survive. So what is Sn? That is sum of first n terms. N could be any 20 or 50 or 5 or 200, I don't know. We can see only the first term. I mean, we can write down like in this way: 1 over 1 minus 1 over 2, 1 over 2 minus 1 over 3, 1 over 3 minus 1 over 4, 1 over 4 minus 1 over 5, and keep going. And n, when n is n, when we are taking n equals n, here in the question when n is n, that literally just n. Okay, so the last term would be then 1 over n minus 1 over n plus 1. Okay, from n to n plus 1, n to n plus 1, there is just the jump of 1, just one step. So writing the very last term would be fine. And there will be a lot of cancellation. 1/3 cancel, right? And 1/4 cancel, 1/5 would cancel. And n plus 1, the previous term would have been what? 1 less n minus 1, 1 less n minus 1 over n, that would cancel with here. Like in the previous cases, only the first term, which is 1 over 1, just 1, and the very last, minus 1 over n plus 1. Only these two terms survive. I mean, we can confirm, look at here, there's 1 minus 1/3, here 1 minus 1/4, here 1 minus 1/5. Alright, so Sn is just 2. Now the fun part, using calculus 1, we can, now we let n go infinity, because we are supposed to add infinitely many terms. That would be the sum. And if this sum comes out to be a finite number, then the series converges. Sum will be just limit of nth partial sum, and we let n go infinity. That is n go infinity, n goes to infinity of 1 minus 1 over n plus 1. Okay, and when n is so big, 1 over so big plus 1 so big, 1 over very big is 0. That means what is left? 1. Okay, sum is just 1. Sum is 1, and we can confirm series converges. Okay, and the sum is 1.